Okay, today we're talking about section 4.2. In this section, we're continuing what we did in the last section. We graphed parabolas, and in the last chapter, we solved systems of equations by graphing, meaning that we graphed them and we found out where the equations crossed. In the last section, we graphed parabolas, so what we're going to do in this section is solve a quadratic equation by graphing. So we're going to graph the parabolas, and we're going to talk about what it means to find the solution to that equation. So we have some vocabulary for this section. A quadratic equation is a quadratic function. Remember, the quadratic function is f of x equals ax squared plus bx plus c. But when I set that equal to a value, equal to a number, usually we set it equal to 0 when we're solving, then it's called a quadratic equation instead of a quadratic function. Why is it called an equation? Because it has solutions. And that equation is in standard form when I write it equal to 0. Sometimes you might see it equal to 3 or equal to 5x or something, but you should move everything to one side and make it equal to 0 for the quadratic equation to be written in standard form. What we're looking for when we solve are roots. Roots are the solutions of this quadratic equation that we're trying to solve. The solutions are called the roots. And the x-intercepts are basically the same as the roots. So there are 4 words that mean basically the same thing: root, solution, 0, and x-intercepts. Technically, zeros are x-intercepts and roots are solutions because not every parabola has a solution. And so if they don't have a solution, I should say that differently. They don't all have zeros, meaning they don't all cross the x-axis. And their solutions would be imaginary numbers then, which we'll talk about later in the chapter. So sometimes it can have a solution but not an x-intercept, but in general, these 4 terms mean about the same thing. So a quadratic function, again, this is what I just talked about. F of x equals ax squared plus bx plus c. And if we look at the graph of this quadratic function, we can see that there are 2 x-intercepts, or 2 zeros, at x equals -2 and at x equals +3. And the quadratic equation is when I set it equal to 0, and when I plug those x-intercepts in, I see that I get 0. That's why they're called zeros sometimes, or the roots of the equation. So the roots, the solutions, the x-intercepts, the zeros are basically all the same thing if my parabola crosses the x-axis. All right, so let's solve this equation by graphing. X squared plus 6x plus 8 equals 0. So if you remember from the last section, we used negative b over 2a to get the axis of symmetry. And there's the work for that if you don't remember how to get that, negative b over 2a. And then we're going to do the exact same thing that we did in the last section. We're going to make a table of values. Notice here I start with my x value that is my axis of symmetry, which is also the x-coordinate of my vertex. So 3, -1 is my vertex. And I pick some x values on both sides of -3. And then we're going to graph that. So we look at this table back here. I'm going to graph these 5 points. So you should graph those on your note guide. And when I graph them, it's easy to tell where the zeros are. The zeros are at x equals -4 and x equals -2. So again, if we look at the table, it's easy to tell, as long as they're nice numbers, where the zeros are, because I get y equals 0 when I plug them in. And when I look at the graph, I'm looking for the x-intercepts to tell me where the solutions are. So the solutions of this equation are x equals -4 and x equals -2. I can check by substituting into my original equation. So here's my original equation, x squared plus 6x plus 8 equals 0. I'm going to start by checking -4. So I plug that in for x. I get 16 minus 24 plus 8, which is 0. So that works. Then I do the same thing with -2, and I find out that that one works as well. So my solutions are x equals -4 and x equals -2. Okay, now it is time for you guys to try one. Maybe, there we go. So solve this equation by graphing. Make your table of values around your axis of symmetry, graph, and find the zeros. All right, if you solved this correctly, your answer should have been A. So your solutions are x equals -3 and x equals 1. All right, when I graph a parabola, there are three things that can happen. There are only three basically kinds of solutions that it can have. If my parabola touches the x-axis at only one point, meaning that its vertex is on the x-axis, the x-intercept is the vertex, then I have one real solution, because remember, the solution is where it crosses the x-axis. It's the zero, it's the root. If my parabola crosses the x-axis twice, which is the most normal situation, because of the curved shape of the parabola, I have two real solutions. So if it crosses the x-axis, my solutions are real numbers. But sometimes my parabola could be floating above the x-axis, or it could also be, if it's opening down, it could be floating below the x-axis. If it does not touch the x-axis, it has no real solution. We will learn later in this chapter that it will have complex or imaginary solutions that we will be able to find. But for right now, we would just say no real solution. So let's take a look at this one. We're going to graph this parabola. X squared minus 4x equals negative 4. The first thing is always to set it equal to 0 before you start graphing. So we're going to add 4 to both sides, and we get x squared minus 4x plus 4 equals 0. And we're going to graph the related function, right? So our equation is equal to 0, but we're going to graph the entire function y equals x squared minus 4x plus 4 to find out where it crosses 0, or where it crosses the x-axis. So we plug in, find the axis of symmetry, and set up a table. And if you do x equals negative b over 2a, we get x equals 2. So that's my axis of symmetry and also the x-coordinate of my vertex. So you plug in a couple x values above 2 and below 2, and we get our y values. You can see from the table that it's only going to cross 0 at one place. So if I graph that, the vertex actually turns out to be the only x-intercept. So the only solution, there's one solution, is 2, or x equals 2. And that is because the vertex is the x-intercept. So I want you guys to try this one. Do the whole process of graphing. Don't forget to set it equal to 0 before you start. And then identify which graph shows the correct solution. Okay, you should have gotten A in this one. Your vertex should be 3, 0. You should have graphed all 5 points to get your good parabola shape. And your solution would be x equals 3. Okay, sometimes we can have a situation where we can use a quadratic equation to solve a word problem. So in this case, we're going to use a quadratic equation to find two numbers that have a sum of 4, meaning they add up to 4, and a product, meaning they multiply to 5. So if my numbers have to add up to 4, my first number is going to be x. And if I want to find out what the other number is, it's going to be 4 minus x. Why? Because if I do x plus 4 minus x, I get x minus x, which is 0, and I'm just left with 4. So that's how I arrange them to make sure that they add up to 4. What I need to set up for my equation is this: the product is 5. So my first number is x. My second number is 4 minus x. I multiply those together, and their product is 5, meaning it has to equal 5. So we distribute the x. X times 4 is 4x. X times negative x is negative x squared. And then I'm going to set it equal to 0 so that it is in the correct standard form of a quadratic equation. X squared minus 4x plus 5 equals 0. So now to solve this, we're going to graph our function. To do that, we're going to do x equals negative b over 2a. And when I do that, I get x equals 2. So that's my axis of symmetry and the x-coordinate of my vertex. And so we're going to make a table, which they've already done, and they're not really showing it to you here, so I'll draw it for you. This is what your table might look like. Here in the middle, I have my vertex. When I get x equals 2 and I plug it in, I get 1. I picked 2 x values on either side of my vertex, and notice that when I graph, my parabola never touches the x-axis. That means that there's no real solution. So when I take into account that this is a word problem and I go back here, that means there are no numbers that have a sum of 4 and a product of 5. So there are no two numbers that add up to 4 and multiply to 5. And I can do that using a quadratic equation. I could check and try to see if anything would work. What numbers add up to 4? Well, 1 and 4. 1 times 4 is 4, not 5. 2 plus 2 is 4, but 2 times 2 is also 4, not 5. And you could do multiple examples like that, and you would have a hard time finding, because it's impossible, two numbers that add up to 4 and multiply to 5. So I want you guys to try this one, same idea. Okay, the answer in this one is D. No such numbers exist, but on your notes I should see the work to back that up, including the table and the graph. Okay, sometimes we know that when I solve a quadratic equation, my solutions are not always going to be integers. So sometimes we have to estimate solutions, especially when we're solving by graphing. So sometimes we cannot find the exact roots. So what we're going to do is we're going to say, okay, well, I might not know exactly where it is, but I can tell that it's between 1 and 2, or it's between 3 and 4. So let's think about what that means in a table. In a table, I can look at my y values. So here my y value is positive 12, positive 3, and then negative 6. And if I think about what that means, so for example, the point negative 3, 12 would be up here. The point negative 2, 3 would be about here, and the point negative 1, negative 6 would be down here. Well, since this is a parabola, not a very beautiful one that I'm drawing, but it has to cross the x-axis somewhere between these 2 points, because it goes from a positive y value to a negative y value. So it goes from above the x-axis to below the x-axis. That's the point here, that when my y value changes from positive to negative, there has to be at least 1 0 between those two values. Remember, the value of my function is the y value. So when my function value goes from positive to negative, there has to be a 0 somewhere between there. So in this case, we would know that there is a 0 between negative 2 and negative 1, even though I didn't draw it super great. So let's look at this example. Negative x squared plus 4x minus 1 equals 0 by graphing. We're going to make our table of values just like we normally do. I'm going to leave it to you to make that same table using x equals negative b over 2a to get that middle vertex value. And then we graph. When I graph, I can tell that my roots are not exact. I can also tell that from the table, because my y value here goes from negative to positive. So somewhere between x equals 0 and x equals 1, there has to be a 0 or a root. And then over here again, it goes from positive to negative. So since there's a change in the sign of the y value, it has to cross the x-axis somewhere between 3 and 4. And when we graph, we can see that there's a 0 between 0 and 1. So x has to be something between 0 and 1, and something between 3 and 4. Okay, you guys try that same thing with this one. All right, if you graphed, you should have seen that the 0 is between 0 and 1, and between 3 and 4 in this graph as well. And again, I can see that from my table. Here, I can see that my y value goes from negative to positive. That means that I have to have a root, or a 0, somewhere between these x values, between 1 and 0. I can also see there's a change in negative to positive in the y values from negative 1 to 2 down here, which means that my graph would cross the x-axis between 3 and 4. Okay, for the last minute, we're just going to look at how the graphing calculator can sometimes help us to solve these things as well. So if you look here, I have graphed the function y equals x squared plus 5x minus 7. And your calculator can also generate a table. So I can kind of see here that my 0 would be between 1 and 2, or it would be between negative 6 and negative 7. So if we go to actions in our graphing calculator, actually if we go to view, we can show the table. And when I bring up my table, I can look just like I would in a table that I made, where does my y value go from negative to positive? So I can look here, and I know that between 1 and 2, it goes from negative 1 on the y to positive 7. So there has to be a 0 between 1 and 2, and there also has to be a 0 between negative 6 and negative 7, because y goes from negative to positive. And I can make that more specific by editing my table settings and making my table step by 0.1 instead of just by 1. And now I can see that between negative 6.1 and negative 6.2 there has to be